Hello friends, welcome to this video, and in this video we are going to learn about the properties of NumPy array. So let's get started. First we are going to import the NumPy library. Import NumPy as np. Now in my previous video you have seen how we can create NumPy arrays, and here we can create two NumPy arrays. First a one dimension and second a two dimension array. So let's create them. If you haven't watched my previous video, then click on the I button and you can see that video. Dtype, specifying the data type, that is integer 16, creating one more a two-dimensional array, specifically NumPy array. And again giving the same data type. Running this cell. Now we're going to print the values within these NumPy array. So you can see 1 2 3. So it's a one dimensional array. Now let's run this. Now you can see the value 1 2 3 4 5 6 correct values, and it's a two dimensional array. So now the question arises, how can you just say that this is a two dimension, this is one dimensional array? So there comes its first property, that is its shape. From its shape you can determine the number of the dimension of a NumPy array. So first the variable a dot and then write the shape. From there you will get the shape of that NumPy array. Now we'll run this cell. So you can see the shape of the x is 3, it has only 3 elements, and the shape of y is 2, 3. It's a two dimension, it's shape in two dimensions. So dimension, if like this x dot shape return a tuple with only one element in, so it's one dimension, and the y dot shape return a tuple with two elements, so it's two dimensional. So from here you can say that it's the x is one dimension and y is two dimension. Again from the shape you can get this value of the shape and the number of dimension, but there is also another property, that is the number of dimension. You can specifically get the number of dimension using the ndim property. And y dot ndim. So you can see x has dimension one dimensional and the y is two dimensional. You can also create a three dimensional array and you will get the same a shape of with three elements in it, and the ndim property will be 3, that is indicating a three dimension. So next is the data type. If we have any NumPy array and we don't know what its data type is, we can simply use the data type property. Same x dot the NumPy array name and the value property is dtype. Print y dot dtype. Run this cell and we get this data type. So you can see the data type is integer 16 as we specified above. Data type is integer 16. Now if we just change them and you will see that same data type is specified above. So next we are going to the size property. The size tells you the number of elements in them. Y dot size. Let's run this. So let's calculate and see first. So x has 3 elements, so x should be 3 and the y side should be 6. So let's run this cell and see. So you can see x has 3 elements, so size is 3. Y has 6 elements, so size is 6. Okay. And next property is the size in terms of number of bytes, the size in memory. You can easily calculate it without just seeing. Just see that it has 3 elements, it has 6, and their data type is integer 16. So it's going to take 2 bytes. So 3 into 2 is 6. So the size of x in terms of byte is 6, and size of y in terms of byte is 12. So let me just check that fact. X dot nbytes. Print y dot nbytes. So let's run this. So you can see they've got exactly the same answer. 6. The x has taken 6 bytes of space in the RAM, and the y has taken 12 bytes of space in the RAM. So this indicating the size in terms of the memory management. Now the last property is the transpose. How you can get the transpose of a NumPy array? any numpy array, whether 1 dimension, 2 dimension, 3. So the thing is that all these properties can be any numpy array have all these properties. So now the last property is the transpose. Let's get the transpose. Same, just variable name numpy array name dot and then capital T. Now let's run this cell. So you can see the transpose, no change, but you will see the change in a 2-dimensional array. Now you can see its transpose. Above you can see 1 2 3 4 5 6. Now here you can see 1 4 2 5 3 6. So this is the transpose of this y. As x is 1 dimension, so there is no change in its transpose. Its transpose remains the same. So these are all the 6 properties that any numpy array have. So this is going to help you in future with any kind of problem you just when you use numpy, and it also going to be used in our future videos. So that's all for this video. If you like the video, then hit the like button, share it with your friend, and also subscribe to my channel for more content. Thank you. Have a nice day.